All right, so yesterday we were talking about m to the fifth power, and we said that m was called the what again? Base, and that the 5 was called the exponent. Okay? Now, today, we are turning this whole thing into a base of its own. So all of this now is going to be a base, and by putting parentheses around it, we are then going to take it to the third power. Yes. Everything that's in parentheses. So in this case, m to the fifth power raised to the third power would mean m to the fifth times m to the fifth times m to the fifth. Right? It means we take m to the fifth times itself 3 times. And we just learned when you are multiplying powers that have the same base, you keep the base and you add the exponents, right? So the final answer here would be m to the 15th, right? But instead of writing all that out, when you raise a power to a power, you can just multiply the 3 and distribute it with every exponent inside. So final answer there, m to the 5 times 3 is m to the 15th, same as it is here. So all you need to do is to check and make sure that your factors have an exponent, and then whatever's on the outside, that's too wide, come on. Whatever's on the outside, that gets multiplied by all the exponents on the inside. So this is n to the 5 times 3, which is n to the 15th. The one below it is x to the 4 times 2, so that is x to the 8th. Yeah, but that's only, this is the basics. Yes. Okay. So then we move on to the next page, and we're taking a power, not just of a power itself, but a power of a product. So we have several things on the inside of this parentheses. Okay. First of all, I'm going to look at this. It's a monomial to the 5th power. Okay. I need to put an exponent and make sure I have an exponent on each one of these factors. 3 is a factor. X to the 5th is a factor because we are multiplying. So if you don't see an exponent, like Beyonce says, put a 1 on it. Oh, 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 oh. Yeah, okay. I can tell you really love that one. All right, so then this whole thing is taken to the 5th power. So distribute that 5 with every exponent on the inside. So this is the 3 to the 1 times 5 times x to the 5 times 5 times y to the 2 times 5. And then we simplify and say 3 to the 5th, x to the, what is that? I can't read it. I can't read it. Say it.
I said, did you do this right? I said, did I do this right?
I don't know. Did you?
That's why I'm asking.
That's what I'm asking. X to the 25th, y to the 10th. Is that in simplest form? No, why not? Yeah, can't we figure out what 3 to the 5th power is? I hope you might have a calculator. On your calculator, do you remember how to take 3 to the 5th power? It is 3 the little caret symbol, and 5. I don't think it's 60. What is it? 243? So 243 times x to the 25th times y to the 10th. And that is in simplest form. Is that what you have?
Yes.
So you got it right. I'm an old lady. I can't hear. All right, let's take a look at B. Oh, wait. So I like to think of a power or a product of powers as you are distributing that 5. And when you are distributing it, everything gets multiplied. Sita, head up, please. All right, let's go to the next one. Now, anytime you have a negative number and it's raised to some power, I want you to put the negative number in parentheses. I know it's an extra little, 2 little lines. I think you'll make it though. And I don't have an exponent on that 5, so put a 1 on it. All right, so all of these products, all of these factors are being taken to the power of 2. So I need to multiply and say -5 in parentheses to the 1 times 2 times a to the 1 times 2 times b to the 4 times 2. So we get parentheses -5 to the 2nd power, a to the 2nd power, b to the 8th power. And on your calculator, put -5 in parentheses to the 2nd power, and what do you get? Did you put your 5 in parentheses? Does it make a difference? Yes, it does. People, I can go over this many, many, many times. I would like to go over it just once. So everybody, eyes up here, listen one time as I'm talking. When you put -5 squared in the calculator, this is what your calculator sees. It says, oh, they're squaring 5, which we all know squaring 5 is 25. And it says, okay, and then I'm going to multiply it by -1. And that gives the -25. But that is not correct, because we want -5 squared. You have to, on your calculator, put it in parentheses, okay? The calculator is only as smart as you are in putting it in. I'm not saying anything bad about you, but you've got to put it in correctly. This says -5 is being squared, and that will get you +25. This is how you have to do it. This is why every time we have a negative number taken to some power, I will tell you to put it in parentheses. Okay? So if you put -5 parentheses squared in, you will get +25. A squared b to the 8th. Okay? Do you understand what I'm saying and how the calculator calculates it? If you just say -5 squared, all it sees is 5 squared times a -1, and it's going to be wrong every single time. Okay? You have to put it in parentheses. All right? Okay. Let's go to C. Oh, Miss Sadie, we've got a negative exponent. What do I do with that? Well, follow the process. First of all, make sure all of your factors have an exponent. The 4 doesn't. Put a 1 on it. X to the third, y to the negative second. Everything is then taken to the power of 3. So multiply your outside exponent times all the inside exponents. That is 4 to the 1 times 3, x to the 3 times 3, and y to the negative 2 times 3. So when I simplify, I get 4 to the third, x to the 9th, and y to the negative 6. Now, where did I get what? The negative 2 was written in the problem. Okay. It's kind of fuzzy. All right. So 4 to the third. You can figure that out on your calculator. Put 4 caret 3, 4 caret 3, and tell me what you get. 64. So 64, x to the 9th, but here we have a negative exponent. You cannot have negative exponents. So what do we do? Nope. When you have a negative exponent, think of it as being in bunk beds. Okay? It is in the top bunk. It's in the numerator right now. And it is negative. Okay? If you're in the top bunk, you usually want to be in the bottom bunk. Or if you're in the bottom bunk, you want to be in the top bunk. You never want to be in the bunk that you're actually assigned. Okay? So this gets moved down into the denominator. It goes from the top bunk or the numerator down to the denominator and becomes over y to the positive 6. So when you move it from the top to the bottom, it's happy. It loses its negativity. I did. And put it in the bottom part of the fraction.
Also, it's a fraction now.
Yes. It goes in the denominator. And if you have a negative exponent in the denominator, you move it into the numerator and you remove the negative amount.
The other one wasn't a fraction, though.
Which one?
A? Is that a fraction?
A?
Part A.
Part A. No, but we don't have anything. That's all in the numerator. There's no negative exponents. Only if it's a negative exponent. Right, Darren? Okay. All right, let's go to the last example. We have a negative value. Head up, come on. I'm going to write it down. Negative 3 to the first power. Put a 1 on it. Oh, 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 oh. Yeah, I'm going to say that every single time, Darren. And hopefully you guys remember. B doesn't have an exponent. Put a 1 on it. Oh, oh, oh. You want to sing it with me, Darren? No? Okay. So here's the 6. It gets distributed or multiplied with every other exponent. So that's negative 3 in parentheses to the 1 times 6. A to the negative 3 times 6. And B to the 1 times 6. Is this making some sense? Are you sure?
Nah, it is.
I hope so. All right, so putting this all together, I have negative 3 to the 6th, A to the what power? Negative 18, and B to the 6th. Ooh, I forgot my parentheses out front. Better put those down or Miss D's going to yell at me. So negative 3 to the 6th power. Put that in on your calculator and make sure you use parentheses. What is negative 3 to the 6th power? 759? 729. All right, a to the negative 18th power. It's a negative exponent. It doesn't like being in the numerator. So put it down in the denominator and remove the negative amount. Remove the negative sign. It's happier on the bottom bunk. Think of it that way. And then the last one, b to the 6th. It's not a negative exponent. It likes being where it is. And that is the answer for that problem. I'm sorry? This one? All right. So this is everything that we were to have covered yesterday. Now we get to move on to what we are supposed to cover for today. So turn the page. Let's talk division. Let's talk division. My friend, keep that away. All right, so division uses quotient of powers, okay? We can multiply these all out. Hey, is the floor okay back there? Okay, just check. 2 to the 8th power means you are multiplying 2 times itself 8 times. Come on, guys, please. Stay with me. 2 to the 8th power divided by 2 to the 3rd power. You can write these out and you can see how we can simplify out. You guys often say cancel out, but it's really simplify these out to be a 1 in front. So it's 1 times 2 times 2 times 2 times 2 times 2, which is 2 to the 5th. Okay? We have r to the 5th divided by r to the 4th. And you see how we cancel out 4 of the ones on top and 4 of the ones on bottom, and we're left with 1r, which is the same as just r. Sherman. Why don't we use the 5? Well, here's what I'm going to tell you. Instead of writing these out all the time, when we were multiplying, we added the exponents, right? So when we are dividing them now, we are going to subtract. Because 2 to the 5th is the same as 2 to the 8th minus 3, which gives you that 2 to the 5th, where we don't have to write it out. R to the 5th divided by r to the 4th, you are dividing powers that have the same base. So you keep the base, r, and you subtract the exponents. 5 minus 4 is 1. And r to the 1st, you can just say is r. So this is just the same as multiplying powers with the same base. We added the exponents. Now we're dividing powers with the same base. So we subtract the exponents. Here it is, right here. To divide 2 powers with the same base, keep the base and subtract the exponents. That is the key phrase. Might want to circle it. To divide 2 powers with the same base, keep the base, subtract the exponents. So they give us a couple of examples. B to the 12th divided by B to the 9th. You keep the B and you subtract. 12 minus 9 gives you B to the 3rd. W to the 6th divided by W to the 2nd. You keep the base same base, and you subtract the exponents. 6 minus 2 becomes w to the fourth. Let's go to example 1. I think that's at the top of your next page, isn't it? So we have one monomial divided by another monomial. I'm checking first to make sure they all have exponents. I don't have one on the c in the denominator. So put a 1 on it. Oh, 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 oh. I know. You guys love it when I do that. So b to the fifth divided by b to the second. You keep the b and subtract the exponents. C to the seventh divided by c to the first. You keep the c, subtract the exponents. So this becomes b to the third and c to the sixth.
So, are we ever allowed to add the exponents?
Well, if you are multiplying and you have a to the seventh and you have a b here to the fifth and maybe you have another a to the fourth, then you would do a to the 7 plus 4, right? So when they're being multiplied, you add. But when they're being divided, one on top of the other, you subtract. Okay? Does everybody understand that? Uh-huh. All right, let's go to the next one, which I think is some checking. All right, so here we go. A squared, b to the ninth, c, doesn't have anything on it, put a 1 on it. The c in the bottom doesn't have anything on it, put a 1 on it. All right, now, as I look at these, the ones that have the same base are being divided. They're one on top of the other, right? So a squared, there is no other a in there. You just leave it as it is. A squared. Then I have b to the ninth divided by b to the eighth. We are dividing. So you keep the base and you subtract. Now, you can either write it like this, 9 minus 8, or sometimes I would just put it in the middle there and show it vertically, 9 minus 8. Yes? Then we have c to the first divided by c to the first. What can you tell me about c to the first divided by c to the first? Yeah, it's going to simplify out because it's the same variable divided by itself. So that's just a 1 when you simplify. And then finally we have d to the fourth divided by d to the third. So you keep the d and you can subtract the exponents. Or you can do it this way. So if I were to simplify this, this would be a squared b to the first d to the first. But do I really need that first as the exponent? No. If you write it like this, I will take that. Or if you write it as a squared times b times d, I will take that also. This is probably better because it is more simplified. But hey, you're just learning this, okay? So I will take either one of those. Any question on that? All right, let's take a look at letter B. 2 divided by 8. 2 divided by 8. Is that 4? 2 divided by 8? Oh my gosh, so many people are telling me like 2 divided by 4 is 2. No, it's not. 2 divided by 8. You have to simplify. What number divides into both 2 and 8? 2. So you divide by 2 over 2. No, I wanted that smaller. And you're going to get 1. Divide 8 by 2, and you're going to get 4. So you have just simplified the 2 and the 8 to be 1 over 4. Why are we doing fractions? Because fractions come up. So 1 over 4, okay? Well, we haven't done that yet. Now we're doing the x's. I have x to the 4th divided by x to the 9th. You keep the x and you subtract the exponents. So I've just taken care of my x's. How about y's? All I have is 1y. So just leave it as y to the 3rd. It's not being multiplied by anything with the same base of y. It's not being divided. What? It just sits there and looks pretty for right now. And then finally we have z to the 5th divided by z to the 8th. You are dividing, so you will subtract the top exponent 5 minus 8. So as I simplify this, I have 1 over 4. I have x to the what? Negative 5th. Yeah, we'll change that in a minute, but leave it there for now. Y to the 3rd. And z to the 5 minus 8 is going to be negative 3. Now, we just said we can't have negative exponents. So this guy doesn't like being in the numerator, in the top part. So I'm going to rewrite it one more time and say 1 over 4, move x to the 5th down here, lose the minus sign. Y to the 3rd, y likes being up on the top, bunk bed. And z to the negative 3 does not like being in the top bunk bed, so it goes down to the bottom and it loses its negative sign. All right, we did not get through everything, but listen carefully. Homework, excuse me, easy for me to say. Homework number 1. I really would like for you to look at it, do as much as you can on the front and the back, and come in with your questions tomorrow morning, okay? I would like to try to collect this. All right? Okay. I need to talk to the two of you.